My name is Charles Staten. I'm a geospatial sales engineer here at Nearmap, helping customers and partners integrating our content into third-party applications and answering any technical questions you may have about Nearmap, our processing pipeline, or our capture program. Without further ado, let's go ahead and jump into it. So Nearmap is an aerial imagery provider. We are a software as a service company. We specialize in high resolution aerial imagery that is all distributed and hosted into the cloud. We regularly capture over 70% of the US population and operate in several key verticals, including the solar, roofing, architecture, construction, engineering, and local government space. We have over 8,000 customers and over 72,000 users accessing our content on a daily basis. We have a lot of data stored in the cloud, 2D and 3D, ready to be disseminated to our customers and partners within just a couple weeks of capture. So we have a very quick turnaround time for our content. That's our 2D aerial imagery, our oblique imagery, and then a lot of what we're going to be discussing today is our three-dimensional content, which is actually derived from our latest camera system. So that's a little bit about Nearmap. I believe we have a polling question right now that I'm going to pause and hand it.
36% is winning for extracting site information during a project. And looks like in second place is the mysterious other, Charles. Maybe you can find out what that is.
Okay.
Thanks for sharing, everyone. And back to you, Charles.
Thank you. So here's just a little bit, a sample, a high-level overview of the different types of 2D content that we are able to produce. On the left, we have our Nearmap vertical, which most of you would be familiar with, working with high-resolution aerial imagery. Once again, Nearmap captures all of this imagery from fixed-winged aircraft from between 8,000 and 12,000 feet. Our camera system is proprietary, as well as the processing pipeline, both of which are built in-house in Sydney, Australia, where our company headquarters are located. Nearmap uses two different types of camera systems to produce our suite of content. The first we call HyperCamera 1, or HC1, which produces a 2.8-inch GSD vertical-only image. And then we have, that was our first iteration of our camera system. Then we have developed our latest iteration, which we call HyperCamera 2, or HC2, which produces a 2.2-inch GSD vertical, oblique, as well as we're able to derive three-dimensional content from the oblique camera system, and the 3D content that we produce comes in at a 15-centimeter resolution, okay? And the accuracy statements across all types of our content are horizontally is 28 centimeters of accuracy, and vertically is 40 centimeters of accuracy, 40 centimeters. So most of you are used to the Nearmap vertical, which is on the far left. You're able to conduct measurements that are going to be accurate within 6 inches. In the center, we have Nearmap Panorama, which this is a term local to Nearmap. The way that we produce this is it is a fixed 45-degree angle view of our obliques, but it is in a uninterrupted pan and zoom sort of pattern. So this is not measurable in any way. The panorama, I just want to make sure that that's clear. It is not measurable, but it is great for visualization purposes or orienting yourself in a particular cardinal direction. You're able to do that because our camera system actually sits on the bottom of the aircraft and rotates from 0 to 45 degrees, capturing about 40 to 60 different images that are overlapped on top of each other on every point on the ground that we collect. And those are all ortho-rectified using ground control points into a seamless mosaic that's then hosted into the cloud to be consumed within just a couple weeks of capture. The far right image is a measurable oblique. So I talked about the panorama, which is that fixed 45-degree angle view. Now the obliques are actually capturing the source images from the camera in the aircraft. So we can see here that this is one oblique image that I can look at from a particular look angle from the camera, but I also have the option to look at about 6 to 8 different other look angles from the camera, as well as each cardinal direction as well. That's due to our proprietary camera system, that rotating camera system that I talked about, as well as our flight pattern. So think about, going back and forth, mowing the lawn with that camera system rotating on the bottom of the aircraft. That's how we're able to get all of these different oblique angle images and have them measurable, create the panorama mosaic, and then derive our 3D content from that. So our latest camera system produces obliques, as well as the 3D content that is derived from these obliques, okay? And all of these obliques are with our latest camera system, meaning they have a ground sampling distance of 2.2 inches. And the vertical and horizontal accuracy still stands with this content as well. So horizontally 28 centimeters and vertically 40 centimeters. So those are a little bit the types of our 2D content, what goes into it. And I believe we have another week for another poll question here.
Esri is the clear winner, but hooray for Autodesk that coming in second place there almost. So thanks for sharing, folks. Lots of Esri users in the crowd.
Thank you. So that was great on the file types. Really good feedback there. I do want to mention we're an Esri Gold partner. So we're one of 88 partners worldwide leveraging that Esri partner network. And because of that, we have several ways to integrate our content into Esri very seamlessly, making it insanely adoptable to ingest our content types into an Esri environment. So now I'm going to turn it over actually to Betsy to talk a little bit about her city of Grapevine, Texas.
Good afternoon, everyone. Glad you're tuning in. Just a little bit about Grapevine, just so it might be more relatable. We're an average small government city in the north central Texas area, in the DFW area. Actually, we're smack dab right in the middle, just north of the airport. We're about 50 plus K in our population size. We are a huge tourist town, so we're always, highlighting things in our community and have a lot of events where public safety comes into play big time. And just a little background on our partnership with Nearmap is I run the GIS shop here in Grapevine, and I've been in local government GIS for almost, I'm going to say 30 years. So I've had several relationships with imagery vendors out there, and I will say that over time, Nearmap has really increased their resolution and their accuracy to our base map here in North Texas. And whereas about 10 years ago, we relied heavily on a Council of Governments imagery, and now we've shifted to where Nearmap is pretty much all we use. So we're very, very, very happy with the partnership there and the solutions that they've provided to us. We utilize their 2D, their obliques, and just recently we purchased their 3D data, and Charles and I will be showcasing some of that stuff. And then I'm going to speak to now how we utilize their 2D and obliques to help us prepare for a possible testing site in response to the virus that's going on. When the police chief and fire chief approached me, they said we're going to possibly have a mobile testing site at one of our recreation centers that obviously had been closed because of the social distancing and things like that. And they wanted to utilize that property to bring people in. And, I was like, okay, well, you get a roadmap, this and that. And they said, no, actually, we want to be prepared for the volume of people that might be coming through this site. And we need to have a very detailed traffic pattern. So I immediately leaned on Nearmap on the accuracy of their data. We have a subscription with them where we live in a very populated area, so we actually have high-res photography taken 3 times a year. So this photography that you're looking at here was actually taken in February, and it was on my desktop by the end of the month. I think it was February 6th when it was flown. So the turnaround time for imagery, and this is 6-inch imagery, is amazing. I mean, it's great. So as you can see here, we have the imagery in the background, and I worked with public safety officials to kind of get a route set. And then the next step was to, where do we need to put barricades to make sure that people aren't trying to come in behind, and just, from a preparedness standpoint. And I think everyone can relate to how everyone's kind of possibly in a panic mode, how this situation with this many people might get a little hairy. So they really wanted to streamline the route through the parking lot, as you can see down there on the south side. Another part where we prepared for this was using the oblique imagery. And that brought in the fact that the library was just south of where this proposed site was going to be. And although closed, they still wanted their patrons to be able to drop off books at the book drop. And so we used the obliques to kind of see how narrow was that road and how we could get people in and out of there, as opposed to in the past they'd come in from the north. So having the obliques there really helped, I guess, ease the mind of the public safety officials that were developing this traffic route map. And then also from this, this is within the Esri platform. We use a web map service that's consumed by ArcMap, so we can bring in our data on top of it. We also measured how many, as a capacity planning thing from an emergency standpoint, how many people, how many cars could we get into this route and be safe. So, as you can see in the legend, you can see the length of the car. And ironically, this mobile testing route was exactly a mile. I thought I actually found humor in that, if you're a geospatial junkie like me. And then we could propose how many cars you could have, as city management was working with the county health department. For people to get into this line, they needed it's almost kind of like a waiver or a certification, if you will, from their physician stating, yes, they are exhibiting symptoms and they need testing. And this was early on in the response to COVID. So they really wanted to know how many people they could accept. So, they have an officer posted down there at the entrance of this. And, once they have that many cars, then they need to start turning people away and saying, hey, you need to come back on this date. But overall, the imagery provided a great foundation to not only routing, but also kind of satiate the worry of public safety. They really saw what they were dealing with.
Awesome. Thank you, Betsy. This is a great example of how local governments are able to leverage Nearmap for these particular types of use cases, just as Betsy mentioned. Thank you. I think we have one more polling question, our last one.
Not terribly surprised that we have a very clear winner in satellite or drone imagery services. Makes good sense. All right. Thanks for sharing, folks. It's a good insight.
All right, thank you. So now I want to dive into a little bit of the use case and some examples of what we're going to be going over today, and then sort of the environment that they're going to be in. From our web hosted platform, there are a couple ways that you're able to leverage this type of data. This is an example of our customer-driven 3D export from our map browser. So what I've done is exported an area in SLPK format, scene layer package, so it can be dragged and dropped directly into ArcGIS Pro or hosted as a layer on ArcGIS Online if you want to have more collaboration on it. In this scenario here, I'm placing security cameras on the top of this building for a parking lot view shed analysis. So I've placed the view shed here and drawn out the view shed based on parameters of the camera. So everything in green you would be able to see from this vantage point. And then everything in that purple or pink color would actually be outside of your line of sight or view shed. This is very helpful in determining blind allocating resources in sort of the planning phase of any emergency events. So let's say we needed to cover this parking lot from several sides and eliminate some blind spots. Well, we can see up in the upper right-hand portion, I've placed a security camera there with a view shed. And then in the bottom one, I've placed another one on the top of this building here. And to model view sheds sort of decreasing or completely eliminating, in this case, blind spots, the areas shown in yellow are indicated by this area is viewable by 2 or more view sheds. You could even do this in reverse by covering ingress and egress points by officers or allocating resources based on road closures or directional ways, barricades like we saw in Betsy's example. You could essentially recreate that entire scenario right here in an ArcGIS Pro session to better allocate resources and plan for these events in such an in-depth way. Okay, so let's talk about this situation for Grapevine, Texas. For the 4th of July fireworks specifically, this is a fun example. So here I have cut out a SLPK file type from Grapevine, Texas. I have went in there and Betsy shared with me the location that they're going to be setting the fireworks off. And I've done a little bit of research and just done a small mock-up version here of what this event would look like on a smaller scale so that somebody maybe behind a desk can figure out where to allocate resources. And so you can plan in 3D. Perfect. And to give you guys some dimensions here, I've done a little bit of research and found that an average fireworks display will erupt around 730 feet, and then a blast radius, an explosion of a firework can be anywhere from 200 to 600 or 700 feet, depending on what type of firework it is. So I just wanted to give a little bit of a model overview of what people would be able to see based on their viewpoints here. And now Betsy has shared with me that this is a large event and people often will be out in the water here as well, watching from their boats. So really, this sounds like a fantastic display here with 360-degree views of these fireworks where people are able to set up and watch this show take place. I've actually never been to Grapevine, Texas, but actually I have just to meet Betsy one time, but never to this location. So I just thought, okay, where are some locations that I would like to see fireworks from, and picked out a couple locations here that I think would be good viewing perspectives. So this one here at the bottom, I saw this field about 2,500 feet away, based on, what's a good viewing distance for fireworks? Well, if these are, the industrial size ones, you can watch them from the baseball fields, out in the lake, really anywhere. But what would it be like looking at it from this perspective and showing a view shed in this field here? So as I drag it out, we can kind of see the tops of those trees are green. And then the rest of this area is actually that pink or purple color. So we can see where our obstructions are by the tops of these trees here, looking out over the water. Now, obviously, as you look up, that view shed is going to be able to see more of the fireworks and less of the ground clutter and trees down below. But if you really enjoy watching fireworks come out of nowhere beyond treetops, this would be a great viewing space, maybe away from the crowds that would be a little bit closer. So that was my first stab at it, and I thought, well, let's move a little bit closer down into this area here along this road. we can place the view shed there, and maybe people can set up and park their cars, lay some blankets down, or some low back chairs to get a good viewing angle of all the fireworks that could happen within this view distance. So that is pretty up close, but it's about 1,000, 1,500 feet away, so still a safe, manageable distance. Really prime viewing distance for fireworks, as I've just found out. About 1,000 to 1,500 feet away is great. But as Betsy mentioned, people are going to come from all around and line up on the baseball fields and in the lake. So this is a great way to visualize that display.
And to follow up what Charles has shown, so from the front end on preparedness, there's two things. It's going to be public safety, number one, and then number two, marketing these fireworks. We are a small town, however, we're right on a lake here in North Texas, and in the summer, it's really nice to be close to water because it is very hot. So our emergency management office, over the years have dealt with this, huge influx of population of people coming from, several entities, 3 or 4 entities away from us, people from Dallas, people from Fort Worth coming in to view our fireworks. And it became a safety issue because we had so many people. So not only are we trying to identify, what we needed to identify was where can people see the fireworks to market it, but also to prepare, okay, this park can only have, this is the capacity of people for this area. As I said, in the past, we've had some issues with too many people coming into our parks. So utilizing this 3D data, as Charles mentioned, they came and saw me this past fall, and they showcased this 3D data, and I said, this is exactly what we need for our fireworks capacity planning from a safety perspective. And it's great because, we have geography all across the city, so we bring into Esri, we bring in this visibility analysis into ArcGIS Pro, and then we overlay our parks, our landmarks, our big, huge parking garages or parking lots where we know people are going to show up. And then so through this 3D analysis with this data, it tells us what parking lots and parks and, buildings that we need to analyze on a capacity level. How many people can we get in here safely so everyone enjoys the 4th of July and it's not chaos and, people sitting on top of one another. So from a where should I go to enjoy this to a, okay, hey, we really need to make sure that we don't have too many people in this park so it doesn't get out of hand. And it was a huge win when we purchased this data. We're in the process right now preparing for 4th of July. It sounds like it's going to be reality for us here in North Texas. So again, the 3D data in an ArcGIS platform, in ArcGIS Pro specifically, the visibility analysis is not available with this type of data in ArcMap, but AGP, it's super, super easy. And I'll hand it back over to Charles.
Awesome. Thank you, Betsy. Yeah, really driving home the value there of using one content type for multiple situations. And that's really, what we want to try to drive home is, you use it once for many different things. So thank you for that. This was a great analysis. And then, determining and highlighting view zones. Of course, you could put them here in the baseball fields or the first field as well, and then categorize them by distance, just making sure everybody has a good view, and then also everyone is staying safe. So a great use case here. And now let's go into the second part, which is going to really focus around event management. So the situation of having the World Series at Chase Field, you're going to need to allocate a lot of resources for events as large as this. So what we've done here is exported a scene layer package and place it in ArcGIS Pro. You can see the Chase Field and surrounding areas where we're going to need to allocate our resources can clearly be seen from this good vantage point and showcase to determine, all right, where do we need to plan and where do we need to prepare? So then you can place your main exits, ingress and egress points, so you can get your perspective. Okay, where do we need to put resources, and where are most of the people going to be allocated, as well as placing our security personnel during something event like this. So you can cover the main exits. You can allocate more security personnel on the buildings surrounding it, and then run a viewshed analysis, like I mentioned before, in reverse, to make sure that all of your blind spots are covered by one or multiple viewsheds. And then we can see here placing your resources to allocate things like a road closure. These are simple multi-patch features that you can create in ArcGIS Pro. They have a really great library of icons and little things like police cars, security cameras, all kinds of construction equipment, to really get everybody on the same page, and then represent them in real world units so that your measurements and analysis can be that much more accurate. Again, all of this is coming in at 15 centimeter resolution. All of it is the same across the board in very dense or more urban or rural, excuse me, locations. And you can see here, you can place buffers around your resources so that you can say, all right, no one is going to be more than 20 to 25 yards away from someone else. This is our staging area and our command center, where we have our servers up and running. Many people and officers would be looking at things like this and having a constant feed and allocation of where to plan resources and how to effectively prepare for something, an event this large. So you can have your staging area here where your vehicles go, your command center where all of your analysis is being run, and then even things like conducting a feasibility analysis. Okay, where can we land a helicopter if we have an emergency situation and someone needs to be airlifted to the hospital because the roads are closed? Where can I land a helicopter? What's the safest spot, and how can we block that off quickly? Heaven forbid, another situation arise and something was caught on a security camera. Well, we need to place security cameras at each of these access points and then model a view shed to know, all right, are we going to be able to see around here? What is our vantage point or line of sight going to be from this particular camera? So security cameras, traffic camera placement, viewshed analysis inside of ArcGIS Pro is a great use case for situations like this. And then, the ultimate bad situation is having, an active shooter scenario, and then where are we going to allocate sniper positions, and what is their view shed going to be like? Introducing blind spots and maybe covering that by another sniper situation so that we can see those areas in yellow, like I mentioned previously, are covered by 2 or more view sheds. This is a great way utilizing the textured mesh. This is our reality mesh in ways that you can visualize these events taking place or being prepared so that they never have to, which is the really big value here. Okay. And I guess I will turn it back over to ask any of the chat questions